All right, in this video, we're going to take a look at how to make a solution. So the first thing I have here is some pictures of equipment that we use to make a solution. So we can see here, if you're making a solution, you're going to need a volumetric flask. You're going to need some distilled water. We always use distilled water when making a solution. Okay, so a volumetric flask, keep in mind, has a line, and that to that line we know the volume. So if this is a 500 milliliter volumetric flask, we know that at the line, if the water is at the line, we know exactly we've made 500 milliliters of solution. So and one more thing to know, as you're making a solution, don't fill it up all the way with distilled water. Fill it most of the way up, like you can see in step B, swirling it, letting the solute down here dissolve into the solvent. And the reason you do that is because you fill it up all the way to the line and dissolve it, you might go over. So once the cap is on too, you can invert this. You can flip it upside down to make a solution. So we'll go through this in class, and I'll make a video of me making a solution, but it's an important skill for a chemist to have, so I wanted to make sure that you could do it. And let's take a look at an example of a calculation you would make when making a solution. All right, so let's take a look at the problem. A chemist needs 1 liter of an aqueous 0.2 molar potassium dichromate solution. How much potassium dichromate must be weighed out to make this solution? Well, again, the first thing we need to do is figure out the formula of potassium dichromate. So potassium dichromate, so we know it's potassium. We can look on our ion list and see dichromate is Cr2O7, and it's a 2- charge. Potassium, from looking on the periodic table, is a +1. So the formula of potassium dichromate is K2Cr2O7. So we can calculate the molar mass of potassium dichromate, and if we calculate the molar mass, it comes out to 294.2 grams per mole. So we'll need this information to do this problem. 1 liter of an aqueous 0.2 molar solution. So we need to figure out how many moles of potassium dichromate we need. We know that the relationship is molarity M equals moles over liters. We want to find how many moles of potassium dichromate we need to make this solution. We know the volume of solution we want is 1 liter, and the molarity we want is 0.2. So we know this is 0.2, and we know this is 1. So this is very simple. And do 0.2 equals moles over 1 liter. So the number of moles of K2 potassium dichromate is equal to 0.2 moles. I then multiply that by the molar mass, which is 294.2 grams per mole, and I end up with a number of moles of 58.8 grams of potassium dichromate. So what I would do is I would take this much potassium dichromate, weigh it out, add it to my volumetric flask, like we saw the picture on the earlier slide, and then fill it to the line with water, distilled water. But we would have then a 1 liter of a 0.2 molar potassium dichromate solution.